Hello again, folks. Welcome to Mr. Sespico's backyard again as we think about scientific things. We ponder the meaning of life, the size of space, what's under the ground, etc., etc., etc. Distances, though. Distances in space. That is not a simple thing to think about. And you know, I'll be thinking about it tonight because it's a clear night. I've got the cameras out, as you can see. We left the telescopes inside. Sometimes it's just good to take some still pictures. I'm going to take some still pictures with this one. This one over here, and I hope to show you the product of this. This one I'm going to show you the stars that are circling around the North Star. Okay, that's going to be a 2-hour exposure where there's a bunch of individual exposures where you capture some stars for a little while and then the sky shifts and it happens again and again and again, and you've got this really cool kind of rotational effect. All right, but as I try to focus these cameras in just the right spot, it's not an easy thing, okay? Because you have to focus to what's called infinity, and they're not the best cameras in the world anyway. But when I start to think about just the distance of things in space, I get to thinking, how do we know how far things are in space? Well, there's a pretty simple rule in geometry, or is it trigonometry? I don't know which. I'll have to ask Mrs. Armstrong. But it's called parallax. Parallax, okay? Is the star that I'm looking at up there, is it only 4 light years away? Is it 8 light years away, like the brightest star that's in the sky? 4.3 light years is the closest star in the sky. Is it something way beyond that, like Betelgeuse, which is, some people say it could be up to 600 light years away. Well, there's controversy with those ones that are farther away. The farther you go away, the more difficult it is to figure out what their actual distance is. And I'm going to try to explain why. Okay? So let's say right position between these two cameras is the sun. Okay? And here, let's say we have the Earth in December. And over here we have the Earth that's in June. Okay, it's orbited, excuse me, it's orbited around the sun, and we're looking at stars in the background. Okay, and those stars, they've shifted, right? They've shifted. Well, here's why they shift, and you can do this really crazy experiment in the comfort of your couch. Okay, and that is this. Okay, put your finger in front of your face. Okay, open one eye, close the other. And then switch, and then switch, and then switch, and switch, back and forth. Okay, you see your finger moving. Okay, based on your eyeball that's perceiving it. Okay, but your one eyeball over here is a little bit farther away than this eyeball over here, and as a result, we see a shift in the position of your finger, and that's called parallax. Okay, but if you hold your finger farther out, you're going to notice that it does not shift quite as much every time you open and close your eyes. Okay? Well, that's also the same as, so kind of picture these cameras as your eyeballs. Let's say this is your, I don't know, right eye, this is your left eye. Okay? And if you're viewing these stars in the background from this vantage point in December, okay, it's going to look like those stars have shifted position from your viewpoint in, what do I call that? June. Okay? So yeah, 6 months away from each other, you are on a completely different side of the sun. Okay? And that's parallax. Parallax is good for measuring stuff up to about 400 light years away. Okay? Any farther than that, parallax just doesn't work, because that shift in position of an individual star does not move enough in order to be measurable. Okay? But a really cool geometric relationship, though, that the scientists have figured out, is that between these two positions, if you have a triangle drawn, or legs of a triangle drawn from those two spots, and they come together here and they join together to form this tiny little angle of what's called an arc second. Okay, the distance at which that happens, and this is another word in your textbook that you should have come across, is the distance at which that happens is called 1 parsec. You've heard us talk about light years, but now parsecs are longer than light years, and they're exactly 3.26 light years. Okay, so that sounds like a random number, but it's not, because it's a geometric thing, where those legs of the triangle, they join and they create 1 arc second of separation in the background, and that happens to be 3.26 light years away. Okay. One other application of what a parsec is, besides the fact that they happen to say it in one of the episodes of Star Wars, and it's pretty cool, and I get all excited about that scene. Something with Han Solo's Kessel Run. Anyway, it is taking a look at the brightnesses of stars. Okay, so when I look at the stars tonight, I'm going to see that on Earth that they're all different brightnesses, right? We learned in our textbook that is called apparent magnitude. Okay, they all have different appearances to them, all right, because A, they're different sizes to begin with, and B, they're all different distances away. Well, what absolute magnitude does is it eliminates the variability of the distance thing. Okay, what absolute magnitude does is it uses at 10 parsecs away, at a standard distance of 10 parsecs, which is 3.26 light years times 10, which is 32.60 light years away. At the distance of 32.6 light years away, it takes a look at the brightness of a star and says, okay, this one has a brightness of this amount. That star over here has an actual brightness of that amount, and this star over here has an actual brightness of that amount. Okay, so we have the actual brightness of, let's say, for instance, Betelgeuse, which is a red supergiant, is hundreds and thousands of times more bright than our sun is. And stars that are smaller, like white dwarfs, like red dwarfs, that they don't put out as much light as our sun does. Okay, that their diameters are even different altogether. They're not putting out as much, therefore their absolute magnitude is going to be much lower. Okay, so a lot of little factors to think about when you're looking up at the night sky. But one thing to keep in mind, and that is all the stars that we see, they're really no farther away than about 3,000 light years. And as we know, as we learned about in space, just how ridiculously big space is, and so hopefully we're taking one more step to kind of wrapping our brains around it, and Parallax is one more tool to be able to do that. Okay, stay well, guys, and hopefully I'll see you soon. All right, take care. Bye-bye.